Okay, our speaker today is Troy Carey. Troy is over in Environmental Health and Safety, EH&S. And one of his primary missions is fire safety and fire safety training. So he's done this training for many different departments and buildings on campus. And so he's here to talk to us today. I never remember in my entire time at Iowa State having a seminar on fire safety, so I think it's about time that we do that, since we've already evacuated this building at least twice because of fires. So that should help us. Now, one of the things we have to list on this sign-up sheet that we've been here, so you have to put your name and sign it, and put your ISU ID number if you have one. And
the department, it's all the same department.
PLPM, so
yeah.
Although we may have a few wanderers from elsewhere. But, so
yeah.
While he's talking, you can do that. So it's all yours, Troy.
Okay, thank you.
Oh, one more thing, Troy.
Yeah.
If you want the little printer.
Okay, yeah, that'll work. All right, welcome everyone. I am in Environmental Health and Safety. I'm the manager of the fire safety program within the department, and so in addition to these trainings, we go around and, our primary job is to go around and do inspections of buildings. So, for example, we split the buildings up on campus between 3 of us. I have this building this year. I've already done this building. I did a full walkthrough of the building. We do that for all the buildings on campus, the academic and administrative buildings. We write up violations and then we get them corrected. We also do plan review. So when this building was being designed, we were involved in that process to make sure that it was code compliant, make sure that the fire department and Mary Greeley had adequate access to the building, make sure that we're putting fire extinguishers where fire extinguishers need to be, making sure the sprinkler system is designed properly, all that type of stuff. We also, as I mentioned with the fire extinguishers, we maintain all the fire extinguishers on campus. So if you work in a laboratory in this building, you've probably seen one of our students, usually wearing yellow polo, going around checking fire extinguishers. That's what we hire them to do because we have to do those monthly. So those are some of our primary responsibilities on campus. But a big one is doing training for fire safety and fire extinguisher. Now the way this class typically works in the classroom is we're in here for usually about 35 to 40 minutes talking about various fire safety aspects. And then usually we go outside and do a hands-on, but with the rain and coming, we're not doing that today. So I apologize for that, because that's always the part that everybody likes better than listening to me talk, is going out and doing that. So we offer this class usually spring through fall. I think we're done for this year. But in the spring, when we have our next class, if you want to do a hands-on, we can do that. And I guess I'd make that offer. If you ever want us to come over and just do a hands-on for everybody on a good day, we could do that.
What does a hands-on consist of?
Just using the fire extinguisher. We'll see it at the end of the presentation. I'll show you the training unit we use, and basically everyone has a chance to use a fire extinguisher. So, has anybody ever used a fire extinguisher before? Wow, that's big number. Usually in a class there's like 1 or 2 that have, so I don't know what that says.
That we did the class. I mean,
oh, so you're in the training. Okay, I was in training, then that's fine. And as far as your alarms in the building going off 2 or 3 times since you moved in, we'll check on that and make sure that it's not something system related. That's always the bad thing is when you have your fire alarm system activating because of a fault in the system, because then that gives people the idea that they don't work properly, and we don't want to give that impression. We want to make sure that people know that if needed, whether it's a sprinkler system or fire alarm system, that system's going to work properly. All right. Oops, I didn't mean to do that. So, what we're going to talk about today is we're going to talk about our guidelines for fire prevention and preparing for emergencies. All this is on our website. That we're in the fire section of that. We have our EH&S fire safety guidelines in there. We're going to talk about how to respond to fire emergencies, and then we're going to talk about the correct way to use a fire extinguisher. So to get started, I think everybody's familiar with the fire triangle. You need 3 things in the right combination to get this self-sustaining chemical reaction. You need fuel, you need something to burn. In a research laboratory at Iowa State, we always have something in there that's going to burn, whether it's a flammable liquid, a combustible liquid, paper, cardboard. If it's a shop, it might be wood, it might be oil, whatever the case may be. You have to have something that's going to burn. You also need an oxidizing agent, and typically that's going to be the oxygen in the room. So you're probably familiar with the fact that if you suffocate a fire, if you take the oxygen away from a fire, the fire goes out. And then if you reintroduce oxygen, it can start back up again. So we're never going to obviously be able to get rid of the oxidizing agent in the room. We have to have that. And then we need heat. We need something that's going to start that fire. So ideally what we would do is we would eliminate one of those three sides of the triangle. As I mentioned, we can't eliminate the oxygen. We're probably always going to have something, unless we're in a vault or something with nothing in it, we're always going to have something to burn. And we're usually going to have something that'll spark that fire and get us started. So since we typically can't eliminate one of those three, we just want to make sure they don't come in contact in the right ratio to get this self-sustaining chemical reaction. So we're not going to talk about oxidizing agent, we're going to talk about fuel and heat. So number one on heat source, typically on campus, one of the big ones is electricity, where you have a flammable or combustible material coming in contact with an electrical source. We've had a number of fires on campus with that, where flammable, for example, a flammable liquid will drip on some piece of electricity that has, bare wire or something like that. We had a pretty major one about 10 years ago over in molecular biology, where we had a tube that was running in a piece of equipment, and it was filled with, I don't remember if it's acetone or methanol, but right over it was an electrical wire that was exposed. So when that tube, when it eroded enough that acetone or methanol started dripping down on that electrical, we got a fire, and there was enough combustible material around that, paper and so forth, that stuff caught on fire. And it wasn't a big fire necessarily. The problem is that it was a microscopy laboratory, and so the extinguisher that we had in there was not proper for that lab, because when we put that extinguisher in, when the building was built, that was the right extinguisher. The bigger problem with that was the dry chemical powder in the fire extinguisher got into this piece of equipment that had just been calibrated, and it was like $10,000 to calibrate it or something. But when that got in there, then that piece wasn't calibrated anymore, and we had to get that recalibrated. So there's a couple of lessons to learn on that, and we'll talk about the fire extinguisher selection when we get towards the end. So when we're out doing building inspections and lab inspections, what we're looking at is to make sure that electricity, the electrical outlets, equipment that uses electricity is being used properly and being powered properly. So we want to make sure all high-powered equipment is plugged directly into an outlet, and that's the big things like refrigerators and microwaves and freezers and coolers and things like that. They need to be plugged directly into an outlet and not into an extension cord or a power strip. Do not overload outlets. That's the picture up there in the corner. Basically, we have a duplex outlet that has designed for two things, that has 6 things plugged into it. So the potential there is that you'd overload that outlet and get a fire started at that point. The average electrical cords, as I mentioned on that, it's this type of situation where you might have bare wire exposed, and the insulation's gone off of it. This looks somewhat similar to the fire I mentioned over in molecular biology, where even with this insulation here, some of that had worn away, so it was bare wire that you saw. So when that flammable liquid came in contact with that bare wire, we had fire.
Question?
Yes?
That upper right picture that you have with the 6 plugs going into the 2 sockets, would it be better to have like a multi-plug that has a single?
Oh, that's a good question, and you're one slide ahead of me, because we're going to talk about that on the next slide. And then just general combustible materials away from electrical equipment. So your general combustible materials is not just flammable liquid, but it's also paper, cardboard, wood, things like that. Extension cords are allowed on campus, but they both have limitations on how you can use them. The first for extension cords is temporary use only, which we define as less than 3 days. Okay, when we come and do a lab inspection or building inspection, we can typically tell how long the extension cord's been there, because there'll be a layer of dust built up on it. So it's pretty easy. In that case, that extension cord is not temporary anymore, it's permanent. So you've created permanent wiring, and that's against fire code. But we do recognize that there are times when you need electricity somewhere where there's not an outlet close by, so you have to run that extension cord. So we typically, if we know that it's temporary, we're okay with it. I mean, that's how it's designed, that's what it's designed for. We just don't want it to become a permanent part of the wiring. And I think extension cords may not be a fire risk, and they're not a large fire risk, but there are examples of fires that start because an extension cord has been overloaded, heated up enough, and caught something combustible on fire. Now, the two examples I know of is, I know someone that works at the university that had a freezer, like a home freezer, chest-style freezer, plugged in with an extension cord, and they went on vacation, they came back and half their house was gone because that extension cord was overloaded. The other example that's more relevant to us is over at the University of Iowa last summer, they had an extension cord and it was running across the floor or across the carpeting, and they stacked boxes and stuff on top of it. Well, that extension cord heated up and caught that combustible material on fire, that cardboard, and they got a fire out of that with sprinkler activation, and between the fire, between smoke, between water, it was close to $1 million worth of damage. I mean, that's what the cost was for cleanup and replacement and everything. So they're not just something that you plug in and you forget about them. There is a fire risk involved with them, which is why we limit it to temporary use. The multi-plug strips, these can be used also. These can be used year-round, 365 days a year, but you are limited on what you can plug into them, and you're really limited to office equipment primarily. So your computer, printer, monitor, if you have a television, we've assumed that, the biggest question we get with power strips is more in the laboratory if they have a meter of some sort or a monitor of some sort, that if there's a surge of electricity it would be damaged. We'll allow those to go on there also, but what doesn't go on power strips are like the refrigerators and microwaves and things like that. And from the fire marshal standpoint, we've been written up for things like clock radios, desk fans, because technically those aren't supposed to be on multi-plug power strips. So we probably get more questions on multi-plug strips than just about anything else other than room occupancy. Yeah?
What's the rationale on not putting a little fan or what's the problem?
Well, the problem is those will overload the power strip more than a computer will. I don't see where the problem is, because these are typically rated for 15 amps. They have a breaker on them, but that's what we've been written up for. And there's a directive that came from the state, it's on their website actually, that states here's what you can put on a power strip. And they don't list those types of desk, those small appliance type things. It's primarily the TV or computers, monitors, printers, televisions. It doesn't make a lot of sense, but when they put it right there on their website, and they don't put a lot on their website, but they put that on there, so it's a point of emphasis for them. Now, to be honest, that's only one or two of the inspectors we've had up here that have written those up. Others will look at things and completely ignore that. I'm just telling you what's on the fire marshal's website. So, and like I said, we get a lot of questions on these, so if you have questions about multi-plug strips, let us know, and we can help you out.
Do you have a suggestion?
Yeah.
For example, on these labs, we have, most of the labs, you have a desk close to the window, and that's where the printer and the computer, but some of us have, for example, small, simple microscopes on there. There is a double outlet there, right?
Yeah.
So do you have a suggestion how can we comply, but at the same time have a functional laboratory?
It'd be hard to give a blanket statement on that, because typically what happens is we go lab to lab and we will work with PIs or people in the lab and try to identify a solution. You know, if you go by what's on the fire marshal's website, the microscopes would not be something that you would be able to plug into those. But we can usually find a solution. I mean, usually these labs, when we when we build new buildings, these labs have a lot of outlets. So you're saying there's not enough outlets in all the labs?
No.
No?
Or offices even. They just gave us a couple and they're like, here's the power strips, put everything else on there. Okay.
We could take a look at it. If you want us to come look at your laboratory, we can.
And for example, in cases, sometimes we have equipment, those things are not used at the same time.
Mhm.
You know, and the outlets are, you have to climb under a desk to go to reach that outlet.
Yeah.
Is it possible to have things that are plugged but not on?
Well, you could have stuff on power strips, and the power strip turned off. But I'm not sure if you're talking about microscopes that would be something that would fit within that. I'd have to look at it.
Okay.
They are fairly specific on the document that's on the website for the fire marshal, but we could take a look at it and see if that would be something that.
They're sensitive. Good.
Yeah, I mean that's kind of that's a good point, because that's one of the things that we brought up and why we started letting some of this other equipment on there, is because if they did get electrical surge into them, it would damage components of that piece of equipment. So if that microscope fit in that same thing, then we probably would allow it to be on there, because that's, I mean, we don't want to have a power surge and have equipment fried. I mean, that doesn't do anybody any good. So we've given a little leeway on that. So maybe that's something we could look at. All right, some other ignition sources. Candles are not permitted on campus other than in some special circumstances. Space heaters are not permitted, although we're going to be changing that. Hopefully, since this is a new building, have you been in here in the winter yet? No? Okay. Well, then I guess we'll find out how good the HVAC system is that they designed for you. We do have a couple of space heaters that we're going to allow, because they meet the criteria that the fire marshal's office has established. So I need to change this slide. Hopefully you won't need that. Hopefully you'll be nice and comfortable this year here. I guess we'll see. And then anything under here that falls into hot work requires a permit, and there's a separate training class for that. Probably none of this goes on in this building, at least that you people are doing. But if you ever did any of this type of stuff, you'd have to be in the hot work program. All right, moving on to the fuels. I mean, our two main fuels are flammable and combustible liquids, and then your general combustible materials. All right, so your flammable liquids, typically, you know, we will allow up to 10 gallons of flammable liquid outside of the flammable cabinet, which is what's over there on the top picture. Once you hit that 10-gallon threshold, you either have to get rid of it or you've got to come up with a storage solution, whether it's a cabinet or whether it's a safety can. These both have to be listed by a testing agency, either Underwriters Laboratory or Factory Mutual. So what you'll typically see when you look at the label of one of these is, and you can't really see it in this picture, but I'm sure they're there, it'll either say FM or UL on it. So it has to have one of those listings. The safety cans, if you're using these, we prefer you to have the style that has the handle that you have to pull back and pour out, and not the screw-on cap. The problem with the screw-on cap is they don't get screwed back on, and then the container gets knocked over. We have a chemical spill. These typically will also have flame arresters on the inside of them, so if you look inside of a flammable can, you'll see a steel mesh screen-looking thing. That's a flame arrestor into the can and igniting what's in the can. General combustible material, paper, cardboard, wood, keep that to a minimum. Typically, in most labs, we don't really have problems with general combustible materials. It's just everywhere else in the building we have problems with general combustible materials. Some examples of fires that we've had on campus with this fuel-heat interaction. This is a furnace and a fume hood. And the way that this operation worked was they would come in and turn the furnace on and it had to heat up to like 2200 degrees or something. So they'd start it up and then they'd leave the room and then come back when it was heated up. Probably would have been okay even on this day, but when we went to do the investigation, there was all kinds of combustible material in there. So that combustible material heated up and started a fire within the fume hood. This fire, actually the sprinkler system put this fire out. We had flames from eyewitnesses, flames coming out of the fume hood and going up to where the sprinkler was. But the sprinkler put the fire out, contained it to this room. What's not seen on here is over here there's a glove box with air reactive chemicals. So one of the big fears that the fire department had was if that glove box was breached, then air could get to those reactive chemicals, or the water could get to those chemicals, if they're water reactive. But luckily it wasn't. So all we really had from this is we had to replace the fume hood, and then we had a bunch of water damage. So this lab was out of service for 2 to 3 months while they did that. Over here, we have just a regular drying oven. This was not the one that started the fire. This fire was like 8 years ago. So they had a drying oven like this. They had material inside of it. Their drying oven had a timer on it, and it was set to 7 p.m. when it was supposed to be set to 7 a.m. So it started heating up at 7 p.m., which probably would have been okay, except on the back there was a vent for the heat coming out, and it had a stack of paper towels pushed right up to it. So those paper towels ignited, and that was a big fire. I mean, that was a hot fire. Again, the sprinkler system put that fire out. That lab was down. I think that repair was about $240,000 between the water damage and the lab damage. So we had to replace the lab casework and then the water damage. The good thing with that is that it did have a sprinkler system, because if it didn't, the fire could have gotten up above the ceiling into the attic space and went up and down the whole wing of the building that it was in. So luckily, the fire, and we had just finished that sprinkler system like 2 years before that. So that was good news, even though the fire wasn't good news. Oil baths, I don't know, does anybody in here work with oil baths? Probably not, this is more of a chemistry thing. We had a number of incidents with oil baths. Well, you can see here, there's 4 pictures here. This fire here happened twice in the same laboratory, so it was 5 fires that were hot plate and or oil bath related. So what we recommended to chemistry was update your hot plates, because some of these, it was a hot plate malfunction. Some of them, they were really old, and there are certain models that have had problems over the years. So we recommended they replace their hot plates. When they did their oil baths, they typically used mineral oil, and then mineral oil breaks down quickly. And so what happens is, just to give you an example, like this fire here where the temperature probe is out of place. So it's on a hot plate, there's a dish with mineral oil in it, there's a temperature probe in it. When the temperature probe falls to a certain temperature, it kicks the hot plate on, heats up the mineral oil, and when it gets hot enough, it shuts off. Okay, on, off, which is great until that mineral oil, starts getting lower and lower in the dish, and the temperature probe's not in it anymore. So it never registers that it's too hot, so it never shuts off, and it just keeps running and running. Like I say, same fire, 2 times in the same lab. The rest of them, this was also another one. This one was a hot plate that we believe didn't function properly. This one, the user was not familiar with the controls. They didn't know that they had turned the hot plate part of it on. This one was also probably a hot plate malfunction. So what we did with chemistry and with chemical engineering is recommended if you're going to do oil baths, instead of using mineral oil, use silicone oil, because it's a lot more stable, it doesn't break down as quickly. Now it's way more expensive, but it's going to last you a lot longer. So that's a problem, and these all happened like within a 2 or 3 year period. It was just really weird. Yes?
If the sprinklers went off in this building, how does that, what would happen? Like, is it in the slab, is it in
Nope.
the floor, like how is that?
So the way the sprinkler system works is the only sprinkler that's going to go off is the one that gets hot enough. So if my fire's right here, it's going to heat up, it's going to melt that cover plate off, Cover plate's going to fall off, the sprinkler's going to drop down so that it's below the ceiling level, and it's going to start, and then once that melts, when that gets hot enough, that cover plate's going to melt at about 105 degrees. It's going to fall off. The sprinkler head that drops down is about 155 degrees. So when it gets to 155 degrees, the glass bulb in there is going to break. The water's going to start shooting out and spraying over the room. If this one sprinkler controls this fire, that's the only one that's going to go. But if it starts spreading, you're going to see these other ones go off. So it's not like TV where they all go off at once. It's only the one that, and typically you're not going to have more than 2 sprinkler heads go off. We had one fire, another fire that had 3 sprinklers go off, but that didn't really count because that was a roof fire. And the sprinklers, you know, the glass bulb melted and they started activating like they were supposed to, but they weren't getting water on the fire because the fire was up on the roof. But it kept everything below it wet, so that stuff didn't catch on fire. So what's going to happen is, once water starts flowing, there's going to be it's called a flow switch, and it sends a signal to the fire alarm panel that says we have water activation. That goes to ISU police, and they will send Ames Fire to the building. That's the process. They'll come. If they see that the fire's out, they'll shut the water off outside at the post indicating valve that's outside, and then the water's shut off. Then depending on how things, you know, how they want to, for cleanup and things like that, we can isolate certain parts of the building, so the water's shut off at certain parts of the building, but the rest of the building still has water. So that's kind of how it works. All right, moving on to emergency preparedness. These are the things that you need to be thinking about before you have an emergency. We've had a couple of instances where this did not go that way, where they didn't respond, or they had not planned for an emergency. They had not identified where their emergency equipment was before they had their fire. So these are things we want you to do before you have an emergency. First thing is to know where your exit routes are. We're required to provide at least 44 inches of exit path. Most of our buildings it's going to be way more than that, but that's the minimum. So in this building it's pretty easy. You're basically east and west exits. I mean, it's not a real complicated building. We want to make sure that there's no combustible storage in corridors like this. There are some buildings on campus that are worse than others, so we'll see how this building goes because it usually takes a while to build that up. So we'll see. Also, no storage in the stairwells. Those have to be cleaned. You can see here with the corridors, we probably have a nice wide 6-foot corridor, but with all this stuff stored in it, it's not 6 feet, or it's not 44 inches. So it's going to potentially impede people trying to exit. Worst case scenario, this stuff could catch on fire also. We want to keep the corridors as clean as possible. Fire doors, this is not so much an issue in this building. But what they do is they separate exit corridors and stairwells. So where your fire doors really are your stairwell doors, because we want to make sure that once you go into a stairwell, you're protected. So we want to make sure those doors are closed. They prevent the spread of fire and smoke. So if the fire's out in the building, once you're in the stairwell, you should be safe, as long as that fire door is not working properly. So that's one of the things we really check closely, are fire doors for the stairwells. So for instance, the building here, we have a stairwell here with doors on them. If those doors are closed and latched, then anything that's happening out here from a fire standpoint is not going to get into that stairwell. So when you get into that stairwell, you're protected. If this door was wedged open or it didn't close and latch properly, you'd activate. We see a lot of door wedges like this. We see things holding doors open. For fire doors, they're not supposed to be blocked open at all, unless they have a magnetic hold open device. So basically how this works is, you have a part on the wall and part on the back of the door. It's a magnet that comes together. This part here is tied to the fire alarm system. Once the fire alarm system activates, it releases and this door closes and latches. Typically you don't see a lot of those because they're kind of expensive. In this building we have a sprinkler system, as we pointed out. We have to maintain at least 18 inches of clearance below the sprinkler head. So you can see on the picture, this sprinkler head goes down below the ceiling, and there's a deflector shield on the bottom. And the way it works is once that water starts flowing, it hits that deflector shield and it sprays all over the room. A typical sprinkler head is designed to cover usually anywhere from 150 to about 225 square feet, depending on the type of hazard you have. An office is going to cover more area because there's less fire risk. A laboratory is going to have more sprinklers because it's going to be responsible for a smaller coverage area. But if we have stuff stored up to just underneath that sprinkler head, that water's not going to come out and flow where it needs to. It's going to be like an umbrella when it comes out. We want to make sure that all parts of this room that are covered by this sprinkler get water. If there's too much storage too close to it, it's not going to get full coverage. So basically, in here you would be looking, and it wouldn't necessarily be 18 inches below that cap right now. It's going to be about 19 inches because when that sprinkler comes down after the cap melts, it drops about an inch. So in here, I would recommend about 19 inches of clearance below that sprinkler.
Is the cap made out of like really cheap plastic? I mean, why does it melt before?
Well, there's a couple of pieces like soldered onto it, and that's the part that melts. The adherent is what melts, and it's designed to melt at about 105 degrees. So once that melts, once it reaches 105 degrees, it melts what's adhering it. That cap falls off, and then a sprinkler drops down, and it looks, similar to this one. It's just a pendant sprinkler that drops down. So that's not all, like in your laboratories. If you don't have a lay-in ceiling like this, you'll probably have an exposed sprinkler head that you'll be able to see. But in offices or anything with a lay-in ceiling like this, typically it's a concealed head, concealed sprinkler. All right, maintain access to emergency equipment. You have to have access to fire extinguishers, electrical cabinets if you have to shut off a piece of electricity, and then the alarm pull stations, which we're going to talk about here in another slide. Typically, I believe in this building, all the labs have an extinguisher in them, in addition to the ones that are out, like right here in the corridor. Because I think once you go up in the lab, if I remember right, you've got like a main corridor, and then you've got like a lab corridor. So you've got extinguishers in your laboratory, but then that main corridor also has fire extinguishers in them. So going to an example of not planning for an emergency, about 15 years ago, we had a fire in a building, and the lab had 2 fire extinguishers in it. They used both extinguishers, didn't get the fire out. Started running around to other laboratories and grabbing their fire extinguisher. Well, every time they ran past this big 10-pound extinguisher like that hanging on the wall in the corridor, which was probably better than the ones they had in the labs because they were probably 5-pound extinguishers. So this one was a bigger extinguisher, more powerful, and they just kept running past it. Now luckily, they got that fire out, but when we came the next morning, because this was like at 11 o'clock at night, there were 5 or 6 extinguishers sitting on the floor that they'd used to put that fire out. Because they'd run to all the other labs that were open and grab their fire extinguishers. So, that brings up the emergency maps. We put these in all our buildings. I mean, I'm guessing you have them in here somewhere. Because I think we put those in here before you open, or before the building opened. And what that is just a floor plan that shows where the exits are, where fire extinguishers are. If you have a defibrillator in the building, it shows you where that is. And that gives you a quick reference for where your emergency response equipment is. Also in classrooms, we'll also put these in classrooms. We'll typically have an emergency guide in a classroom, and on the back of that emergency guide is a map of the building or of the floor that it's on. All right, fire emergency response. What our expectations are for you if you have a fire. The first thing we want you to do is pull the fire alarm. What that does is it does 2 things. It activates the fire alarm system in the building, so you get the speakers going saying that there's a fire, fire's been reported, please evacuate the building. It also sends a signal to ISU police. And so when ISU police gets that signal, they contact Ames Fire and gets Ames Fire coming here. ISU Police also responds here. Typically, they're going to respond over here to the west side of the building. That's where the fire department connection is out there. And that's been pre-designated with the fire department that if they have to respond to this building, they're coming to the west side of the building. Step 2, call 911 from a safe location. And the reason we want you to do that is if you pull that pull station and activate the fire alarm, that will tell them that there's an emergency in a certain area, in a certain building, but it's not going to give them a lot of details. The 911 call, you can give more details and say, you know, exact location of the emergency, what the emergency is, are there people hurt, are there people trapped, and then they can pass, ISU Police can pass that information on to the fire department. Step 3, evacuate the building. Close doors and windows if time to shut down hazardous operations. Go directly to your emergency meeting area. So if you look at the emergency maps that are on the wall in the corridor, it will say at the bottom where your designated emergency meeting area is. And what we like is for people to go to that area so we can start accounting for people. You know, if we know people are here, they should respond there. It's not perfect. It's hard to do this at a college campus because it's so transient. You know, you get a new class of people coming in every hour. But it does allow for some accounting. Also, that's where the fire department or the ISU Police will go to provide information. So if you're there, you'll get that information. If you're not there, you know, you're going to be playing telephone around the building trying to keep everybody up to date on what's going on. So that's our 3-step process. So what step's not in there in a fire emergency? Extinguish the fire. Okay? Our policy at Iowa State is that you are not mandated to use a fire extinguisher on a fire. Okay? We can't tell you, you've been through training, now if you have a fire, you will use the fire extinguisher and put the fire out, regardless of how confident you are. Our policy is that it's your choice if you want to use a fire extinguisher. We've had very high success rate with people putting fires out on campus, especially in lab type situations. Okay? But we're not going to tell you, you have to use that fire extinguisher. If we were going to do that, we'd have to provide you way more training than we provide you. So it's your choice, and we're going to talk about a few things you need to consider before you use that fire extinguisher. But I want to make sure everybody's clear on that you don't have to use the fire extinguisher if you don't want to. As you evacuate, you may be confronted with smoke. Stay low. You might have to find another exit. In this building, again, you have 2 exits, so you have 2 choices. If you can't evacuate, you can move to an area of refuge. Typically, it's not so much an issue with sprinkler buildings like this, but some of the unsprinkler buildings, we do have to create areas for people to go if they can't evacuate. So typically, that's a stairwell. Worst case scenario, if you're trapped in your room, call 911 and tell them where you are. Keep in mind that if you call 911 on a cell phone, you may or may not get ISU Police, you might get Ames Police, you might get Story County Sheriff's Department. So you need to be ready to tell them exact information on where you are. And if you're on a phone, worst case scenario than that, get attention from the window. When the fire department comes, they usually show up at one spot and then they walk around the building looking to see if they can identify what's going on. So you can get attention that way. All right, moving on to fire extinguishers. This is how a fire extinguisher, this is basically a fire extinguisher. Nitrogen to it, which is the propellant that forces that powder out. So going back to when you should attempt to use a fire extinguisher, if you're confident, you should only use the extinguisher if the fire alarm's been activated and 911's been called. So if there's multiple people working in the laboratory, someone can go do this stuff while you decide if you're going to fight the fire. I mean, you don't have to do everything. It usually works better that way because if you go and pull the pull station and then come back, that fire is going to potentially be bigger. And we want that fire to be fought when it's as small as possible. So typically, what we recommend, again, is if there's multiple people in the workspace, send someone to do the pull station 911, and you decide if you're going to use the fire extinguisher. The fire is small. We've had high success rate with our lab fires, mainly because people have been in the lab when the fire started. A couple exceptions are the ones that I showed you with the furnace and the drying oven. Obviously, there was nobody in those labs when that started. But typically, when a fire starts in a laboratory, there's somebody in the lab, so the fire is still relatively small. And along with that, very low amount of smoke. The smoke is the more immediate hazard. Typically, when there's a fire fatality, it's from smoke inhalation before the fire hits that person. So you don't want to be in a situation where you're breathing in a lot of that toxic smoke, because it is very toxic. You want to make sure you have an exit, and not just have an exit, but make sure that exit's behind you, so that if I'm fighting the fire over here and I don't get the fire out, I can turn around and walk out the door. Okay, I don't want to get in a situation where the fire gets between me and my exit, because then if I don't get the fire out, how am I going to get out? Okay, so make sure you always have an exit behind you. Make sure the extinguisher is rated for materials involved in the fire. So I gave you an example of that earlier in the presentation with that microscopy lab of molecular biology that we had the methanol or acetone dripping on electrical. We had the right extinguisher in that laboratory for when that laboratory was built and first occupied, but it switched to a different type of laboratory, and we never made that switch because we weren't made aware of it. If you ever think you don't have the right fire extinguisher in your workspace, contact us and we'll come out and take a look at it. Which classes is a fire extinguisher effective on? It's going to tell you on the label. The newer ones all have pictures on them that tell you that this will fight a Class A, Class B, and Class C fire. You see the yellow strips on the side, they say A, B, C on them. So this extinguisher is effective on a Class A, a Class B, and a Class C fire. We have 5 main classifications of fire we're most primarily concerned with. The 3 most common would be the Class A, Class B, and Class C fires. A is solid combustible materials, so your wood, paper, cardboard. A B fire is flammable liquid. A C fire is where electrical equipment's involved. You don't want to use an improper fire extinguisher on that because of the shock hazard, which is why you don't see a lot of water fire extinguishers anymore. That used to be, decades ago, that's all you saw was water fire extinguishers. Water fire extinguishers have their use. They're very good on Class A fires, but there's too much electrical risk to have those. I think we have 7,000 approximately extinguishers in our system. You can probably count on 2 hands the number of water fire extinguishers we have, just because there's not a lot of application for them. Class D fires are combustible metal. I don't know if anybody in here is working with any of that type of stuff. We have had 2 combustible metal fires in the last probably last 18 months, where a combustible metal became exposed to air or water, to water in this case. Those tend to be very high energy fires. We have special fire extinguishers that we will put in the laboratories for that. They're very expensive fire extinguishers. For lithium, for example, which is the fire that we've had twice in the last 18 months, the extinguisher for that particular fire is about $600 to $700, whereas a typical fire extinguisher like this one out here is probably about $60. But that's the hazard. We have to put something in there that's going to fight the hazard. And if somebody's going to be working with this combustible metal, then we have to put something in there that will put it out. Class K fires, cooking fires, vegetable oils, and animal fats, probably you don't really have to worry about that. So of our 7,000 extinguishers, probably 95% are dry chemical extinguishers. They have a very fine chemical powder in them. And then we put nitrogen in the cylinder to propel it out. There's 2 types of powder. There's an ABC powder that will fight Class A, Class B, and Class C fires. And there's a BC powder that will fight B and C fires. Of that 95% of 7,000, probably 98% of those are ABC dry chemical. We have a few BC. Typically those are used on where there's a lot of flammable liquid, so like fuel storage. Most of the rest of the 5% are carbon dioxide fire extinguishers. It works by taking the oxygen away from the fire. Effective on B and C fires. Typically, we're going to use those on C fires for electrical. That's what they're best at. So the extinguishers you have in your laboratory are going to, almost without doubt, be ADC dry chemical. There's going to be a gauge on them. You can check those periodically. We check them when our students come in. The carbon dioxide extinguisher doesn't have a gauge on it, so the only way you can tell if it's full is by weighing it. So kind of check it that way. Using a fire extinguisher is a 4-step process, and it's the acronym P.A.S.S. for pull the pin, aim nozzle, squeeze the handle, scoop side to side. When we do the hands-on part of the class, pull the pin is probably the hardest part because people don't pull it, don't get it out. They might break the plastic seal that's holding it. You can see there's a plastic tie that's holding that in place. They'll break the seal, but then not pull the pin out and drop it. So then when they go to squeeze the handle, it doesn't squeeze. So you can pull the pin, you can stick your finger in the ring pin and yank it out. You can twist it like this person is, kind of like a car key, and twist it forward. It puts tension on this plastic tie and causes it to pop off. Either way, you have to get that pin out before you can use the extinguisher. Once that pin's out, you're going to have the extinguisher in your hand, you're going to aim the nozzle, and you're going to aim at the base of the fire, because that's where the chemical reaction is happening. It's not at the flames, although a lot of people will shoot at the flames. Okay, you got to shoot down here where the reaction's taking place. Once you've aimed, you're going to squeeze the handle, and you're going to squeeze as tight as you can. If you don't squeeze it all the way, it's not going to come out with full force. So squeeze the handle, you get the extinguishing agent coming out, and then you're going to sweep side to side. You're going to cover all parts of that fire with extinguishing agent. Okay, if you don't cover all parts of it, some parts of the fire might go out, some might not. You might get this part of the fire out, but this fire over here is still going, this part's still going. So you need to make sure you get extinguishing agent over all parts of that fire where that chemical reaction is taking place. Typically what we found with people doing the hands-on is once they get the pin out, the rest of it's a piece of cake. Here's an example if we were going outside. That's our training unit. This is a propane fire, or it's propane gas. Those 4 circles in the front represent the base of the fire. So what happens is when he comes up with his fire extinguisher, he starts sweeping side to side, hitting those 4 circles. And this piece of equipment, those circles are like microphones, and they'll pick up if you're doing it correctly. And if you're doing it correctly, it'll cut off the gas supply. If you don't do it correctly, the gas just keeps going and going. These are water fire extinguishers, which I said just a few minutes ago, we don't use water fire extinguishers. We're using the water to hit these circles because they can sense the water hitting them, okay? It says right on the extinguisher, not for actual fire, for training purposes only. So I'll go ahead and watch that again. See how he hits, he goes from left to right, just sweeps back and forth. Sometimes a fire will reignite, just like a real fire. Goes back, hits it again, and it's out. From an on-campus thing we did a few years ago, that's the pan that you saw. Does anybody have any questions about anything I covered or didn't cover? We covered a lot of material in 50 minutes, 45 minutes. Yes?
Is there any circumstances like a building like this where if you can't go down the stairwell with a fire, you should go to the roof?
That's typically not recommended. So like if you were down at the end of the building in those offices down there, how on the upper floors how it's kind of L-shaped, and you've got that wing that's down there. If you were trapped in that wing, your best bet would be to go into that last room to the window and start signaling for help or calling on your cell phone, because they're not going to know to look up on the roof. I suppose if they, if you walked over to the edge and yelled down to them, they would see you, but that's not generally a recommended solution for that. Ames Fire is not really designed necessarily for that kind of rescue. I don't know that their ladder truck is tall enough to get to the ceiling or to the roof of this building. When you figure in the angle that they have to have, I think they've got a 75-foot ladder, and this building is right about 75 feet. So, other questions? Yes?
How many fires that require use of a fire extinguisher?
In a year, we're typically looking at about 8 to 10 fires in a year. Combination of lab fire, I mean that's all types of fire, not just lab fires, but 8 to 10 to maybe 12. I mean every year we'll have 1 or 2 vehicle fires that ISU police will put out with one of their fire extinguishers. We'll typically have a half a dozen lab fires, and then maybe 1 or 2 other fires. Other questions? Yes?
Who pays for the damages, you know?
Well, that's a good question. And someone that's a PI would know this better than me, but we have a minimum. So our insurance company is Travelers Insurance, and we have a deductible that we have to pay if we want them to cover a claim. And that deductible is like $1 million, depending on the building. So if that damage is less than $1 million, typically it's going to be the department that pays for it, is my understanding. So like those fires I was telling you about, like the $250,000 one, that department probably had to pay for that work. Now, I guess there is insurance that some PIs have, so that if they do have fire, and I'm not familiar with that really, but I guess you can get insurance, so that if you do have a fire, you might have a deductible to that, but then they'll cover the rest of the cost of that, like for equipment and so forth. But until you get up to one of those big, and since I've been here, there's only been one event that's reached that deductible stage, and that was that roof fire that I talked about. So everything else has been, $250,000 or less. It would run through risk management. They'd be able to give you better answers than I would on that. But if you use a fire extinguisher on a fire, alright, so I guess backing up a little bit, we maintain the fire extinguishers on campus, and if you have a fire extinguisher in your laboratory, you're responsible for paying for the maintenance of that, for the inspections and the testing, okay? If you have a fire that you use a fire extinguisher, we won't charge you for refill the extinguisher, because you've used the extinguisher the way you should use it. So we don't want people to think, well, if I shoot this fire extinguisher off, it's going to cost me $50, so I'm just going to let it, I'm not going to use it. I'll use something else. So, yeah.
So we had a couple of fire alarms and went outside, and I think it was the first one that seemed to be somebody's lunch, and the second one that was also someone's lunch, and the fireman was kind of nasty and yelled about that. Whose responsibility is it to have the fire alarm in the right spot? And if your lunch is burning, how are you supposed to prevent the fire people?
A couple of things. First of all, they shouldn't be nasty to you because we pay a significant chunk of their budget. The university does, and so it's more of a partnership than they are responding to us. So they really shouldn't be that way to you. But typically, if it's the same location, we probably would look at, do we need to have that smoke detector in there? Can we move it somewhere else in the room?
So that would be you guys.
Typically, yeah.
So do you look into every time there's a fire alarm that's not planned and exactly why, and should it be?
I get a report every month of the fire alarms that were activated the previous month, so I can see what the cause was, the location. Every once in a while, you'll find in this similar to this where the same device goes off 2 or 3 times, so we know there's an issue there, and we'll go address that issue. So if there's a cooking situation, we could maybe look at that.
So is there something an individual can do?
Yeah, don't walk away from the microwave. The easiest thing. Because typically when we do the investigations on that type of thing, it's that they put something in, like popcorn or something, and then they walk thinking, all right, well, I got a couple of minutes, and then they get a phone call or something like that. And 10 minutes later, it's still going. So that would be my number one recommendation, is if you're going to use it, don't walk away from it. If it's a recurring incident, same location, we would look at potentially moving that device, and then deciding if we even need that device. But I do see all the fire alarms that go off. In academic and administrative buildings, we don't cover DOR residence buildings, but I see all the others. Anytime the fire department responds, or if an alarm goes off and they call off the fire department, I see those also.
That's all the time we have.
Okay.
Thanks, Troy.